All right, everybody. Thank you for your patience. Let's get started. My name is Mark Schaefer. I am the project manager at iNEMI that is coordinating the counterfeit component tech topic series that we're starting here today. I wanted to let everybody know that you should be on mute, but I'll also try to watch as people come on and make sure that we keep the line as quiet as we can. I would ask that you please use the Q&A function to ask questions so that we can have a transcript of those, and we will basically hold all the questions to the end of the presentations and then address those. I will unmute you if I can. If not, I'll just ask the questions as they come up at the end of the session. I want to let everybody know we are recording the session. The recording and the copy of these slides will be available within the next couple of days. We'll make sure that everybody that registered gets these. I do want to let you know that we don't want to be restrictive of anybody concerned about saying anything online. So once we get into the actual Q&A session, we're going to cut off the recording so you can have the presentation, but the Q&A won't be recorded. So hopefully that will make you feel a little more open about asking any questions. So we do know that this topic is sensitive for some folks. But we have three speakers today. Ben Germain from Intel, Michelle Lamb from IBM, and Charles Wojciech from Skywater. Let me see if I can advance my slides here. There we go. As I said, this is the first in our series, so you can go to the iNEMI calendar and find information on all three of the series, as well as how to register. I also will put in the chat window the registration links for the second and third. And we also do have an open survey on counterfeit components that we have asked folks to please do. Some folks have done it. It has been open for about a month or so, but we wanted to run these two sessions, and then we'll close it after the second session. And then in our third session, one of the topics that we'll talk about is what did we hear in that survey. That will be anonymized data. We're not sharing anybody's specific data, but we'll be looking at sort of it in aggregate and try to talk about what are some of the trends that we're maybe seeing in industry or things that we hear from you on a somewhat consistent basis. And then lastly, these are the next two sessions. Session 2 is going to be about counterfeit management and best practices. And the speakers that we have there are Michael Lazarian, Robert Smith, and Michael Ford. And then session 3 on December 7th, that is going to be on emerging trends in counterfeit detection and mitigation, as well as the survey results that we are going to be going over. And right now we have Navid Zanjani and Terry Munson speaking. Might have another speaker, maybe not. We're still working on that. And it's possible that we may have some sessions into next year. These are what we have set up right now. So if you are interested in these sessions, I'd ask you to please register. As I said, I'll drop that in the chat window. And if you are interested in sharing your story or talking about counterfeits, please do send me a note directly. Like I said, we are looking for additional speakers and may have additional sessions next year. But with that, I'm going to turn it over to Ben. And thank you for your attention.
Yeah, thank you, Mark. Appreciate the introduction here, and humbled to be a part of this series and speak with everyone. Just want to, really start off by thanking those of you that are in attendance and for even showing up and demonstrating an interest in this topic. As Mark sort of said, this is an area that iNEMI is sort of seeking to gauge some member interest in and determining, is there more of an opportunity to provide some additional education and services and resources in this area. So the fact that you're here is a clear indication that this is an important topic to members and something that's worthy of all of our time. I'm going to attempt to sort of frame this topic, I suppose, and kick it off and provide just a real high-level basic overview of a few examples of the ways that counterfeit risks can manifest throughout the supply chain. And then I'll hand it off to Michelle, who will actually go into a couple of examples and case studies that her company has managed through. For counterfeit risk as a topic, it's something that I'm very involved with and interested in at the moment. My role specifically, as you can see here, is focused on security and defending the supply chain. And I tend to see firsthand how many of these threats that counterfeits can present on a daily basis. But that said, there's lots of others in the company who also manage counterfeit risk. And that can range from folks in legal and government affairs, the quality and reliability perspective, or engineering and manufacturing perspective, right? To me, this is kind of what makes the field of counterfeit prevention overall so interesting. Is it's a risk that really spans across a lot of different disciplines and domains, and requires an enterprise-wide coordinated approach. It can't just be a security or a quality issue alone. It really requires expertise from a lot of different areas of the company coming together. So regardless of whatever your individual role or your position is in your company, I do think it's safe to say that there is a lot of focus and attention on this topic of counterfeit risk right now, and just ensuring that all of us as an industry are working to instill that confidence in the products that we're selling out into the market, and just the numerous risks that are present across the supply chain. Here at my company, we're being asked by our customers every single day now, how can I trust that the product that you're shipping to me is authentic and untainted and uncontaminated and it's secure, because it's important to my end customer, or it's so vital to the end use application. And this is something that's really important for all of us in this electronics industry to remember, that counterfeit products and components can and do have real world consequences, very serious implications for health and safety and security and mission success. So it is a vitally important topic that we all really need to be talking about and focused on. I figured the best way to do this was sort of go through framing the conversation around the end-to-end value chain, or the supply chain operations reference model that we see here. If you're not familiar, this is really just a linear depiction of kind of the general hardware supply chain and the different phases that are involved, from designing a product and building it to actually getting it out the door and delivering it to the customer. And in starting with framing it around this model, it can kind of give us that foundation to talk about the different ways that risk can show up in different areas of the value chain. My hope is no matter what area that you work in, again, whether that's engineering or production or purchasing or shipping, what have you, that we can highlight where these inherent risks are across these different pillars, and you can start to consider how your company will avoid or accept those risks, or mitigate them, or defer them, et cetera. I also want to caveat just quickly, this is by no means meant to be an exhaustive representation of all the risk vectors across the supply chain. There's undoubtedly many others that could be added to each of these pillars. And in fact, I encourage that feedback and questions at the end, because that's the exact kind of dialogue that we're sort of hoping to create with these sessions. By no means do I pretend to be a subject matter expert in this stuff. If you see something that's not represented, call it out, and let's have a conversation about it, and consider what else needs to be brought up. But yeah, I'll start off here. Counterfeit risk is really just simply rooted in one of the most basic concepts of supply and demand economics. Wherever there is scarcity, there arises an opportunity to be exploited for economic gain. And there's just so many ways that scarcity can manifest in our industry, scarcity of supply, whether it's an intentional or unintentional, and it creates that possibility for someone to step in and take advantage or sell something that's inauthentic or misrepresented. So we'll start on the left side of the diagram here, where we've got design and planning phases, where new products are initially conceived and created. There's a lot of things to consider here from counterfeit risk perspective. If you just take new product introduction, or NPI, how that intellectual property or the particular product design is manifested. Is it completely an organic design, or is it something that's loosely based off of an existing design that either intentionally or unintentionally mimics some other product that might already be out there in the marketplace? Certainly the bill of materials, or the BOM creation, is an important thing to consider in this phase. You have to think about every single part and component that is intended to go into that finished goods assembly. It should be evaluated for risk, and Consider the availability of each of those components from your individual suppliers over the lifetime of the product, because obsolete components in that BOM will create just a prime opportunity for counterfeits to be used as substitutes inadvertently. And that also leads to the consideration of the overall product lifecycle plan. When parts and components go obsolete is when counterfeit risk arises and substitutes rush in to fill that void. So we have to consider the full timeline and the end of life components for that long-term support to our customers and availability in secondary markets. All of those are ways that counterfeit risk can show up. As we shift to the next pillar, the sourcing pillar, this, in my opinion, really strikes at the core of where a lot of the risk in counterfeiting originates from. It occurs when, at the most basic concept, there's a transaction between a buyer and a seller occurring. And it is one of the most critical areas to be vigilant in and ensure that those proper controls and counterfeit prevention controls are in place. Risk can originate from who and how you purchase through different channels, especially resellers and brokers who often secure inventory out on the open market. Frequently we see OCM suppliers, original component manufacturers, who liquidate excess inventory, and that ends up getting scooped up by a broker, and then somehow those parts get remarked and subsequently sold, posing as something else. So managing excess and overage inventory and controlling how that's distributed into the secondary market is critical. Again, talking about supply forecasting and obsolescence, you should really be considering component availability and supportability over the long term. This is where it's really important to have strong relationships with your OCMs and your authorized distributors to ensure that you have strong collaborative planning and forecasted inventory replenishments in place and considered well into the future, not just on a quarterly basis, but annually, years out in that product life cycle. Additionally, we have to consider things like suppliers' business continuity plans to really ensure that if there is some sort of a disruption caused by some unforecasted event, civil unrest, war, conflict, natural disaster, a cyber breach, or whatever that is, that your supplier can continue to service your demand and you're not forced to suddenly seek supply out on the open market from a broker or an unknown source. To that point also, being able to identify your sources and know who you're buying from is so critically important. Traceability of each and every component is a really, really fundamental component of a counterfeit prevention program. And so without a doubt, the highest risk for counterfeiting occurs when you are forced to go out and source from unknown sellers on that open market. And then lastly here, single sourcing is also closely related, but it carries a tremendous amount of risk from both a continuity of supply perspective and the possibility that your one supplier suffers that unforecasted disruption and leaves you dependent and vulnerable to being cut off from whatever critical component that can only be found from limited distributors and resellers. We'll move into the manufacturing pillar, the make pillar here. We also have, just a number of different risks that can manifest in this area, the supply chain. Proper handling of things like engineering samples, prototypes, and test run products. Personally, I've seen a number of these cases involving counterfeit products that our investigators have later found out originated as sample products, which somehow were leaked outside the factory and made their way to some nefarious party that was able to remark them to appear as new or authentic parts. In this same vein, the way your factory handles scrap and waste material also poses a significant risk for potential counterfeiting. If that scrap material that's generated during the manufacturing process is not properly dispositioned and preferably rendered unusable on site, then there will exist a very high possibility that those components are going to somehow inadvertently find their way back into the supply chain at some point downstream. And we definitely see this a lot in the real world, unfortunately. And finally here, there's the possibility of just, straight up cloning or replicating a product that can also pose a serious risk in the manufacturing space. I might argue this might be more common of a risk with kind of low-tech commodities and consumer goods. Think of things like Nike shoes and Prada handbags and things like that, compared to stuff from our industry, electronics, which definitely involves more significant intellectual property and a certain amount of knowledge to really replicate effectively and at scale. But nevertheless, it is something to be considered in the manufacturing process. We'll move on to the deliver pillar here, this area of the supply chain where there's the risk of counterfeit components being simply inserted or substituted into known good inventory without the shipper or the consignor's knowledge. I think Michelle actually has a pretty interesting example of how her company worked to mitigate this risk coming up in her section next. Which is pretty cool. But additionally, so much of our industry is driven by the utilization of third-party 3PL logistics providers now, freight forwarders, brokers, integrators, all who are really tendering cargo and loads to unknown third, fourth, fifth parties, and all of whom we as the OEM or the shipper really have no direct relationship with. And so it's vital to have visibility into that supply chain and know who's handling your assets and really the real-time location of the assets at any given time. The good news is here there's many solutions and technologies currently available out in the market that are able to provide that real-time tracking and visibility and the verifiable chain of custody to have reassurance around the integrity of your assets and your products as they're moving from A to B to C to D and so on. Further, this is also where we frequently see things like customs and border authorities getting involved in seizures of counterfeit goods at ports and border crossings as sellers are misrepresenting what's included on their shipping manifest. And a lot of that is driven by gray market sellers who may or may not be shipping product as an authorized or franchise distributor. So there's a lot of risk involved in this logistics and warehousing space when it comes to who's handling the raw materials or the finished goods products that we're going to be shipping on to our customers. And then lastly here, the return pillar is certainly an area that's ripe with its own unique form of risks, especially from that finished goods perspective. This is typically where we'll see things like warranty and returns fraud occurring, which also often involves customers who are attempting to send back totally fake or counterfeit components in order to receive some form of compensation back from the company. I'm sure a lot of us have juicy stories, myself included, of customers who have attempted to scam money back from the company by sending back in a product which is just blatantly falsified or altered, or even a completely different product, and claiming that, oh, they don't know how it got that way, or oh, conveniently can't recall who they bought it from or where it came from, right? We see that a lot. But we also see legitimate customers who attempt to return counterfeit products that they unknowingly purchased from an unauthorized reseller, something like eBay or some of these other secondary markets. And that really hurts the brand value and the image, right, of our company. How do we respond in a situation where we have to turn away an innocent customer that unwittingly purchased a counterfeit product and deny them tech support or deny them a refund? My guess would be it's pretty unlikely that that customer is going to be recommending to purchase ever again from my company the next time. If they receive a net promoter survey or a customer feedback survey, that's a pretty poor experience for them. So it really can do sometimes irreparable harm to the brand image. So anyway, I've done a lot of talking, but hopefully sort of set that stage for getting us to start thinking about just some of the many ways counterfeit risks can manifest here throughout the different phases of the electronic supply chain. Again, by no means is this the exhaustive list. I'm sure there's many more here that we don't have the time to cover, but hopefully this can start to frame that conversation and get it started inside your own companies as we each go back and work on setting up our counterfeit prevention programs. So with that, I'll hand it off to my colleague here, Michelle from IBM, and she's got some great examples from the real world that her team has navigated through and implementing. So Michelle, all yours.
Thank you, Ben. Can you give me a signal that you can hear me okay? Just want to make sure. Okay, awesome.
Great,
thank you.
thanks.
Thank you, Mark. All right, so just exactly like how Ben described, right? Counterfeit prevention or fighting counterfeit is really not a one-person show. It's like really you in the enterprise, you do need to have each pillar that Ben described, right? There will be some sort of like mitigation or prevention methodology already in place so that we can have a really truly end-to-end secure supply chain to prevent counterfeit or minimize the risks. Of course, the goal is to eliminate it, but I think many of you already know like counterfeit is actually exists long time, like since we have the industry started, I believe, because of when there's a demand and supply, exactly how like Ben described. So one of the way that we work in the industry to fight counterfeit is really actively participate in conversation like this, right? Like with this session started, and including IBM ourselves. And in my organization, I'm in a supply chain engineering organization. And part of the beginning of this session, also my VP Jennifer Muncie in IBM supply chain is actively participate in this conversation. And unfortunately, she cannot make it because of some medical emergency. But I promise you, I will do my best to deliver what she set out to do, right? Which is to bring awareness, like Ben said, and also share our experience so that everybody can maybe learn from what we have experienced. Then you can go back and also strengthen and secure your counterfeit prevention program. So next slide, right? So just to get set the stage of what I'm going to go into, how many examples? 4 examples I'm going to share with all of you. 2 of them will be under the pillar that how Ben described under source and make, related to broker buy sourcing kind of scenario. And then I'm going to go into more in the return side. Sometimes there will be coming back from the reverse supply chain area that we observe some of the counterfeit activity there. And lastly, and I'm going to have another wrap-up example showing in order to secure the whole end-to-end supply chain, we really need to focus on not just in individual pillar, but also in transition, like logistics, the 3PL, the deliver pillar that Ben was pointing toward. So let's get into the first 2 examples that I want to share with all of you. If you, Mark, you can stay at that slide for a little bit there. I do want to set the stage that why would we suddenly see these 2 examples I'm going to share, which is tied to everybody know in the pandemic timeframe. So before pandemic, the counterfeit it's already exists and is affected by a lot of natural disaster could cause a counterfeit to happen because of the supply decrease, right? And in the COVID time, because of the lockdown and a lot of reason, the supply definitely obviously will be decreased. And then as we come out from our COVID time, like for example, I myself, right, I don't need a car in the past, and then suddenly I need to go back to work. I think everybody know that shortage issue affecting that in the automobiles industry world, demand increase, and that create a significant opportunity for counterfeit to take advantage of. And I have an example here at the bottom of the label. As we come out from the pandemic time, everybody scramble for parts, and we started to observe many. So we have no choice. We really need to go to the broker in some cases, right? We need to assess the risk, but then we need to also meet the balancing the production demand and also like the revenue related, like how do we meet the demand of our customer. So we started to see a lot of broker will approach us with offering that has label that's being redacted. So here is a generic example of that. We actually cover the part number is actually the part number underneath, but the redacted part is really the Sharpie area that you can see, the black region. They will actually scrape, like kind of covering the 2D barcode and the part number to prevent the buyer to really trace back what are these components originally sell to. So there is some telltale there that we're a little bit concerned about part that we purchased from the broker. So if you go to the next slide, Mark, thank you. This is an example of example one that we actually encounter during the post-pandemic time. So one of our product require a specific speed and temperature grade modules to be put into our final production. And we've been looking for that for like asking for, go through our approved vendor list, right? And go to our authorized distributor if they have the product. And none of them have that installed. And a little while later, there's a broker A actually offer us, say, hey, is this what you need? We have this specific modules that you're looking for. And so because of the pressure, like I said, right, demand and supply, we're fighting this struggling with a shortage. So we reluctantly need to like consider that. And in our program, we actually need to have this because of the off-spec buy or broker buy. We will actually pass this module through a process called deviation quality control process. And throughout that investigation or testing to check the product's authenticity, we did notice that there is something fishy about it. And on the left-hand side, that is the label that have a little bit magnified version of how it looks like. We were looking for a commercial grade, which is the letter C stands for on the right-hand side with a speed 6, and G is RoHS compliance indicator. And that's actually what we are looking for on the modules that we want. But as we look closer, there's another, like on the left-hand side, it showed that it's a dual function, meaning it can also have I, it's on the left-hand side, on the I, it's actually the industry grading speed, and 7 is a speed that is a bit slower than what we want, and G, again, RoHS compliance. So we feel a bit suspicious about that. And then if you look closer also to the how the markings being put in there, it's a little bit off from the original. Looks like the I7G is a bit higher and the C6G is a bit lower. So we determined that it is addition. It is being added after the fact, and to incorrectly depict that is the desired modules. So with this discovery, we actually need to take action and have to really cannot use them anymore. So that actually ended up wasted a lot of time and resource just to try to figure out how do we meet the demand, but ended up we took the risk, right? But then it's ended up still cannot fulfill what we can do. So that is one example. If you go to the next slide. So here's another case of counterfeit example that we have encountered. This time it's a little bit different. The part that we really want, suddenly again, right, broker B appear at the doorstep, say, hey, we have the part you need. And as we go through our deviation quality control process, we actually was quite excited at the beginning because the label is not being redacted. And also the original packaging, it comes with it. It looks like authentic. And with the testing we've done, it did not show that it have undergone any black topping process. So we were like thinking maybe this is actually have some sort of a confidence that maybe this is a good authentic parts. However, as we like dig deeper into the data portion, tied back to the traceability item that Ben was mentioning, we discovered that the lot ID and the box ID on this particular part incoming to our shipment is really not taking us anywhere. So there is something not right about this based on that traceability information. And we further like carefully investigate into the marking of the component on the laser marking. We again, we don't see black topping, but then it looks like it could be also it's being the original markings being etched away and being remarked, right? And to the part that we want. But with the pressure on in the supply shortage, we really like not like cannot say, hey, it's a possible suspect. So what we did actually, we still need pass it. We ended up pass it through the production testing for some like a center head example, some center head lot, and check it out. And we unfortunately also discovered that the fall rate is very high. So at the end of the day, we actually really need to conclude that this is a suspicion counterfeit control, counterfeit part, and we cannot use it in our production. So this is another example that counterfeiter actually can do a lot of things to really try to make it very real, that you will think, okay, that might be a good one. We can take the risk and use it. Unfortunately, because of the pandemic, post-pandemic time, it didn't work out very well for us for this, at least these two cases. So moving on to another example, and this time this example it's really more under the return pillar, and which is an example of showing that this type of counterfeit or misbranding could really raise some concern of like brand protection. So these labels on the left-hand side are actually a label on a part failure coming back from the field, and from a customer, and then the customer actually purchased this from an authorized business partner. However, they were being flagged because of the identity of the drive of this part are not matching and not working in the whole system. So with investigating the information on the label with our supplier, we conclude that these parts are actually being rebranded. The label is being printed out to mimic what we have in original supply that we go into the system, integrated to the system to the customers. So we actually collected the evidence and took action against this business partner, and we have to actually remove them from our approved vendor list. So Mark, if you can move to the next example, that will lead me to talk about the last example that I wanted to share with all of you, which is like I mentioned earlier at the beginning, counterfeit is not a one-person job, right? The enterprise needs to have a very good, secure way to secure the whole end-to-end supply chain. And as like a very famous quote that a chain is only as strong as the weakest link. So in our company, we are looking at different weak lane, right? Where we can improve to have secure the supply chain better. And I'm going to give an example of the logistic and shipment transition that we have a project on that to strengthen that portion. And next slide. So this is about system level track and trace program that we have. We actually, for the high value system that we're delivering to our customers, we actually have this track and trace in place, which is, it will monitor the shipment instead of the typical scan A in one point and then you ship it out and you get a scan B already almost at the destination. This is really meant to have close to real-time tracking of the whole shipment to monitor where's the location, and then also on top monitor if it's being tampered with, if there's the health of the product, like the temperature, humidity, the movement of it, shock, and if there's vibration too much to our system, that could cause damage inside of it. That kind of monitoring as well. And so the advantage of this is that, like, if we keep monitoring it, anything happen in between, by the time it get to the customer, if anything needs to be mitigated or any concern that needs to be addressed because of the transportation, we can do that right at the point when it's delivered to our client. So, and why do we want to, like, make sure they're secure? Also because this is actually where counterfeit could be coming from, right? Like, if there's anything happening between the whole shipment of component disappear, it will be in the risk of having it come out in somewhere else as a counterfeit product. So I think that's all the examples that I have to share with all of you. With that said, I'm gonna pass it to Chuck to talk about a different area and how they do the counterfeit prevention in Skywater.
Yeah, thanks a lot, Michelle. So, hey, great talking to all of you. So, my name is Chuck Wychick. I'm from Skywater Technology, and let me kind of just lay out the landscape. So, pretty much my history is IBM. So, I'm an IBMer from Endicott, and when I joined IBM in the 80s, IBM was a vertically integrated company. We did semiconductors, we packaged it, we controlled the whole thing. But as many of you know, this kind of this chain kind of was broken over the years. And so my talk is going to be how we're going to be bringing this back. So the goal of the title of my talk is really onshoring advanced packaging and the impact on counterfeiting. So next slide, please. So what are we? So Skywater, we are the only U.S.-owned pure-play foundry, and we have a front-end semiconductor fab in Bloomington, Minnesota. And I'm going to represent the advanced packaging part, which is in Kissimmee, Florida. So this really came out of outgrowth of Cypress Semiconductor in 2000, or it should be, the numbers got messed up, 2008. And today we're in, we purchased the facility in Kissimmee, Florida, and this is where we're bringing up the advanced packaging. So I don't want to dwell on a lot of the details, but as many of you know, the Moore's Law is running out of steam, and packaging is a key enabler. What's also interesting is in the 80s, the U.S. controlled like 37% of advanced packaging. Today, it's really, beginning of the year, it was 3%. Right now, it's 2%. So the goal is to bring back advanced packaging because, as you know, this is where the integration happens. So this is just a snapshot. Oops, back one slide, please. This is our Kissimmee, Florida facility. What happened is the Osceola County, where we reside, is created this city. It's called Neo City, and the goal is to bring up the high-tech sector in Florida. So right now you can see the fab, which is where we do the advanced packaging on the far right. The middle is the office building where I sit, and then the far left is a STEM high school. So really we're creating a new model where we want to start integrating the future workforce in the semiconductor industry and develop this whole relationship to create the workforce, but really maintain state-of-the-art semiconductor packaging onshore. Next slide, please. So let me talk about packaging, why it's important, and why we're bringing this back. So if you look at the slide right here, this is your typical package. So you have, starting from the bottom, you have the printed circuit board in the green, and then you have the package substrate. And then on top of that, this is where typically this is all done with one monolithic chip. But as you know, the future of the semiconductor industry is to take that large die, disaggregate it into chiplets, okay, or cells or chiplets. So then we stack these chiplets on some type of platform in this gray. One platform is an interposer, the other platform is fan-out wafer level packaging. So that's why I want to talk about advanced packaging, but I also want to talk about what we call now heterogeneous integration. So if you really look at the major players of who two are my colleagues, Intel and IBM, the goal now is not to create this one large monolithic die, but to break these up into individual cells or chiplets. And again, now the thing is, where are those chiplets procured to ensure there's no counterfeiting? Next slide, please. So again, the two pathways to heterogeneous integration are, again, silicon interposer, which I showed before, and then the other one is a reconstituted fan-out wafer, or I'll be talking about fan-out wafer level packaging. And as you can see in these solutions, you can stack the die in a 3D fashion. Typically, the way that's being done today is with solder, but the future is going to be the hybrid bonding. Now, why this is becoming so important is because key customers, and really it started with the defense industrial base, they needed this capability to be onshore, and it doesn't exist. Okay, so this is where what we've seen at SkyWater is a very unique opportunity. But now what we're finding is that many tier 1 commercial customers want the packaging to be onshore, and this gets into design, but really counterfeiting is one of the key aspects of all that, is to make sure that when this gets finally integrated at the packaging house, you're integrating the right type of materials, but also credible semiconductor devices that come from reliable sources. Next slide, please. So again, why is this happening? And I don't want to get into a lot of technical detail, but as you know, semiconductor integration has been very successful with silicon over the past really 40, 50 years. We call this system on a chip. But if you look at a chip, it's really comprised of cells. And again, you have cell A, B, C, D, E, so on and so forth. Now, what's happening is when you start shrinking the nodes of the device to 20 nanometer and less, the cost is no longer there, because typically with Moore's law, you shrunk the node, you got twice as many for the same type of area, and you receive better performance at a lower cost. That was called Moore's law. That's run out of steam. So what's happening now is shrinking is still going to happen, but you can see that the cost to shrink is it's skyrocketing. And the node shrinking is going to happen for only applications that are absolutely necessary. And mainly this is driven by the mobile market. However, the goal now is in packaging, you shrink the cell that needs to be shrunk. In this case, let's say B and probably D, and the others that don't need to be shrunk stay the same, because matter of fact, sometimes shrinking the node decreases performance. So you shrink when you need to, and you integrate now in packaging. So this is why packaging, or what we call heterogeneous integration, is really key to the future of the semiconductor industry. And mainly now the thing is, why is this so key? Because you can design new products very quickly, size, weight, and performance quickly. But one of the cons right now, especially onshore, is there's no infrastructure to do this. So if you look at, and again, many of you know this, if you look at the capability to do this type of integration, it's mainly Asia. And we know that whole story. Okay, so Asia took the ball, very successful, and they're doing this. Now the goal, what we're trying to do is to bring this back onshore. But again, what we're doing is bringing the higher value add technology, mainly for the defensive industrial base. But what's happening is tier 1 customers want this onshore too. Oh, next slide, please. Oh, hello. So if you look at the capabilities for advanced packaging, I'm going to highlight 3 key platforms for heterogeneous integration. First one being silicon interposer, and I'm going to talk about this term called TSV, through silicon via. Second is hybrid bonding. Third is fan-out packaging. Now, eventually, we're going to have solder bumping and assembly. We don't have that right now, but we're going to be bringing that up in the future. But if you look at this on the right-hand side, The front end is being done right now in Bloomington, Minnesota. So Bloomington, Minnesota is a front end semiconductor fab. Okay. Skywater, Florida is advanced packaging with these 3 platforms that I'm going to discuss right now. Now, in the future, as I mentioned, we want to bring in assembly and test. We're not there right now, but we will be in the future. And we also want to bring in future design services. So we could provide a fully integrated solution onshore for a customer. And again, you could see why many customers would want this. Next slide, please. So again, I'm going to highlight this. So the first opportunity for heterogeneous integration is silicon interposer. And basically that's a copper damascene back-end technology, which is very successful, very well known. So again, these are the 4 phases that we're bringing up at Skywater. Phase 1 is really a bridge interposer with a 4-layer metal copper damascene, 1 micron lines and spaces. Phase 2 is a same type of build-up structure on top with a TSV 10 by 100 micron with a backside bump. These 2 are available for customers right now. Phase 3 is a much more complicated. It's a metal insulator, metal capacitor embedded in the build-up with a resistor, same type of TSV, backside RDL. This will be fully available for customers by the end of this year. So by the end of 2023, we'll have phase 1 through 3 offerings. And then phase 4, the one in the yellow, is really a high performance RF solution with a BCB. It's an organic buildup structure on a copper damascene layer, again with the same type of TSV, backside RDL. The plan is to get this capability available for customers by the end of 2024. So again, this is a silicon interposer platform. So as you can see, this is the integration of chiplets onto this platform. Next slide, please. Okay, again, this is a schematic of a 2D type of construction that we're in the process of building right now. So basically you have a silicon interposer coupled with devices on the top, and this gets assembled to a substrate. So next slide, please. So the second opportunity is really hybrid bonding. This is really a very strategic technology for heterogeneous integration. And Skywater has licensed the ADIA technology in California for oxide and hybrid bonding. We have these capabilities that exist right now for silicon to silicon wafers, and we are practicing it right now at our facility here in Kissimmee, Florida, where I sit. So again, because it seems like this meeting is not into really heavy duty technical, I'm just going to outline that basically you could take a oxide wafer to another oxide wafer, bond it successfully, and then you could do what we call hybrid bonding, where you have very fine interconnects of copper on each wafer and you bring them together and bond it. And I'll be showing that in the next slide. So if you look at this hybrid bonding, it's a very sophisticated way to bond interconnects of 2 micron pitch and less at a wafer to wafer. So as you can see, there's a process called CMP that you have to planarize the surface to get the recess. You bring the 2 wafers together, and then you get a perfect copper to copper interconnect. And what I'm just showing here, this is a successfully bonded 200 millimeter wafer with a 4 micron pad, 8 micron pitch on this 200 millimeter wafer, and this is a cross section. So again, a very powerful tool. And why this is important is because the defense industrial base needs it, as well as future tier 1 commercial customers need this technology, and they want to see it onshore. Next slide, please. And I just got done talking about wafer to wafer, but this just shows we have a program here where we're doing die to wafer. So you take a known good die, you can attach that to a wafer and get, again, a very successful type of interconnect. So the goal is wafer to wafer, die to wafer, and right now we have a project underway that we want to evaluate die to die bonding. So again, very powerful tools. for the future strategy for advanced packaging and how to bring those onshore and to maintain them onshore. Next slide, please. So again, the roadmap here just showing we did the wafer-to-wafer oxide bond. The trade name for that from ADIA is called Zybond. We do the wafer-to-wafer DBI. Again, DBI is a trade name for hybrid bonding. And then we're in the process of doing die-to-wafer and die-to-die hybrid bonding for the future. So on this left-hand side, you see a 1 micron pitch. So again, very advanced technology. You can't do this by solder. So what this is saying is that we want to bring up these key enabling packaging technologies to ensure that as we develop onshore semiconductor devices, we have that packaging capability. Next slide. And the third platform that I'm going to be talking about is fan-out. This is a very critical technology. What's interesting is this is heavily practiced in Asia. China, Taiwan, Malaysia, South Korea are doing this very successfully. Essentially, there's no capability right now in the US. There's a little bit being done in a company called Draper Labs in St. Petersburg. But what we want to do is bring up this technology here at Skywater, Florida. So it's a way to embed a die in a molded core and really to do advanced packaging, maintain control of the semiconductor, have topside buildup, backside buildup, very, very powerful packaging technology to really bring up onshore and to maintain it. So this really gets into the roadmap right now. So next year, we're going to be bringing up the, we're in the process of bringing this technology up, but then we want to have in the 2020 timeframe and up the capability to do 200 millimeter, 300 millimeter wafers. Okay, next slide. So how is this important? So as you can see, counterfeiting is a very important part of this whole discussion, but really it gets into the integration, which is the packaging part of it. And part of this is going to really be making sure that what we receive when we package it are trusted parts that are from valid suppliers, either at Skywater or critical suppliers that have a reputation of delivering good products. So where does this start? So right now, Skywater, we have our domestic partners to design this onshore. But as I mentioned before, the plan is to bring up total capability to design these packages here in the U.S. at our Kissimmee facility. So we'll have full control of the design. Now that gets in the next part, sourcing. So we have to have an authorized distributor to procure the materials and also the hardware to build these advanced packages. So as you can see, the focus right now is really heterogeneous integration because as was pointed out, the whole integration of a die and one piece of silicon is going away. So it's going to be integrating these chiplets that are going to be sourced from various suppliers. And now the key thing is to ensure that these chiplets are properly sourced to ensure that we don't have any counterfeit products coming into our facility. So we will work with any customers to provide any unique material or equipment support, and we will have full supplier traceability for our products. So the key thing, making. So this is where now Skywater is really, there's internal work done at the big guys like IBM and Intel on their internal products. But again, Skywater will be a pure play foundry, which is where we will do this for other customers' products. So we'll provide this early prototyping for testing. We'll have the capacity to do low to medium volume, and I know that's a relative term. When I talk about high volume, I'm thinking of companies like ASC, which is a major OSAT, and they talk about like 100 million units and up per year. We're not nowhere near that right now. We will work with customers on scrap disposition. And basically, if you look at Skywater, this will be done in Florida, but basically Skywater, we can consider Skywater as a domestic OSAT. And as you know, many of the major OSATs like ASC, Amcor, JSET, they're all in Asia. And then we will deliver according to our customer specifications. So with that, I'd like to thank you for your time. And I guess where we'll leave it right now is questions for any of our callers.
Yeah, thank you, Chuck. Thanks, Michelle and Ben. Appreciate it very much. I'll just leave the next two sessions up here for now. I will ask Grace, if you're still on the line, if there's anything, I know you were here from the beginning of the inception of this project, if you had anything you'd like to add at this point.
No, first of all, to thank the speakers very much for sharing their experiences and their, I suppose, yeah, exactly, their experiences and kind of maybe the perception of where the greatest challenges are for their areas, because I think the primary objective of this webinar series was really to share kind of the best practices that the industry has learned about, or identify the common stumbling blocks that we can avoid or work as an industry to avoid together. So of course there are many ways for us to address and mitigate counterfeit components in the supply chain. And you know, large organizations will have the resources to do a lot of things, but smaller organizations can really benefit to know what are the more effective ways and approaches that they should take in establishing their supply chain. And we're hopeful that this webinar series and indeed these first few talks have already highlighted that, so it will bring value to the audience.
Thanks, Grace. So I'm going to stop the recording now so that if folks would like to ask questions, that we can do that without concern that it could be shared broader than this audience. So let me just stop that.